Alright, so here in 3.1, we're going to look at a specific type of function, the quadratic functions. Now we've looked at functions in general, and we even looked pretty closely at linear functions, but this is the next step up, the quadratic functions. So a quadratic function can be expressed as this: f of x equals ax squared plus bx plus c. Now that's makes sense because ax squared plus bx plus c equals 0 is what we call the quadratic equation. So this is now a quadratic function, and a, b, and c are constants, the coefficients, and we don't want a to be 0 because if a is 0, then this would just become bx plus c and it would become a line. So we want to keep it as a quadratic function. So as you can see here, the graph of a quadratic function is the very familiar parabola. And this is very nice because our quadratic functions will all look like parabolas. They'll either be like this one facing up, or they'll be like this facing down. And of course we can move them around the plane, but they're always going to look like that, so they're very recognizable. All right. So here's the issue we have to come up with. The ax squared plus bx plus c is nice when we're doing quadratic equations, but when we're doing quadratic functions, we actually prefer what's known as the standard form of the quadratic, where we have f of x is a times a quantity x minus h squared plus k. Now, the reason for this is it gives us some very good information. The vertex is seen in there as the point hk. So h and k are the x and y coordinates of the vertex, which is this point right here. All right, and so that's a very important point of the parabola. And in fact, that h value, which we can get directly from the a and the b that's in the other form, the h is negative b over 2a. So that is also not surprising because you see that in the quadratic equation, and there's a good reason. These two are quite linked. What that is really telling you is that's where this axis of symmetry is. Now specifically, as we're concerned, in this form, it's giving us the x value of that vertex. All right, so this gives you the x value of the vertex. Now, so how would we get the y value k? Well, realize that if h is the y value, is the x value of the vertex, then plugging it in, so doing f of h will give us k. So all we have to do is take the function in any form. So if we have it in this original form here, we could plug h into that and get it. So now we see we have, we can get this very nice standard form of the quadratic that is going to be very helpful in analyzing it. The other thing we should note is that value of a is important. It tells us which way the parabola is facing. So if a is positive, then we get a parabola that's facing upward. And if it's negative, we get a parabola that's opening downwards. So there's a lot we can tell from the equation. So now the biggest challenge is often just getting it into this standard form. And it can be done by two ways. I'm going to show on the first example both ways, and then I think you're going to want to use the formulas to do it, which is nice. I also do want to show you the completing the square way. So let's say we had f of x is x squared minus 8x plus 5, and we wanted to get it to this standard form. So remember, the standard form is f of x equals a x minus h all squared plus k. Okay, so I could do it by completing the square. If you remember how we did this, I said, well, this would come from x plus or minus something squared, and all I had to do is take half of the value here. All right, so half of negative 8 is negative 4. Now, when I square that out, I would get x squared minus 8x plus 16, but that is not what I wanted there. That's too much. I have an extra plus 16. I take it away. I still have the plus 5. So I get x minus h squared minus 11. Or if we want to think about it with the 1 in front of there, which we normally wouldn't write, but just to be clear. So this is f of x is the a, x minus h squared plus k, and I could see, well, we already knew a was 1, and I see that h is 4 and k is negative 11. All right, so now on the other hand, I could use some formulas, because what we know from the original version of the function here is that we have a of 1, b of negative 8, and c of 5. And we already said that h is negative b over 2a, which would be negative 8 over 2 times 1, or in other words, 8 over 2 or 4. So once I have that, then I know that I can get k, because k is just f of h. I already just found that, so f of 4. And I can just go back to the form I already have. I don't need any other form. I just want to calculate it. So that would be 4 squared minus 8 times 4 plus 5, which would give me 16 minus 32 plus 5, which would give me minus 16 plus 5 is minus 11. All right, and then I would just go to my form here and fill those values in. A, we said, was 1. I don't need to put it there, but I just for show here. X minus 4 was h, and then k was minus 11. So let me just fix that 4 there. All right, so there we have it. Either way, we were able to get this standard form. All right, let's try another example. So like I said, here I'm actually just going to do this formula way, because I think that's the way that most of you are going to choose to do it. So I see here from my original that a is negative 3, b is negative 12, and c is negative 7. And with those values, again, we can just go and do h is negative b over 2a. So negative 12 over 2 times negative 3 would give me 12 over negative 6, or negative 2. All right, so that's h, and now I can find k as just doing f of h, or in other words, f of negative 2. So that would be negative 3 times negative 2 squared minus 12 times negative 2 minus 7, which would give us, that's 4, that's negative 12 plus 24 minus 7, so that would be 5. All right, so now that we have h of negative 2 and k of 5, go back to our form, a x minus h squared plus k. Do make note that it is x minus h, and then there's a plus k. So in this one, so our a is still negative 3, x minus h, which was negative 2 squared plus k is 5, so it becomes negative 3 x plus 2 squared plus 5. And so there is our standard form for that quadratic.